So moving right along, we got Alexander and Ang Lee from right here at Google.
Hello.
Take it away.
Is this the clicker?
That's it.
Sweet. Whoops. Okay. Cool. This is apparently multi-device testing, so I'll try and talk about that, I guess. This is Ang Lee, and I'm Alex. In the interest of time, I won't try to pronounce my last name. And we're going to be talking about multi-device testing and end-to-end tests, especially for the mobile environment, the way we do it at Google. And this is, to us, this is an important topic because there's a lot of end-to-end test cases that have to do with mobile devices. The mobile devices need to talk to other devices. They have Bluetooth connectivity, they have NFC connectivity, they have server jobs that are running, they have other hardware you might want to interact with. And we've developed a framework that kind of covers all of these use cases, which I'll get into in a moment. So basically what we're going to talk about is, what are we doing? Why are we doing it? Have we considered not doing it? And the most important is, can I do it too? And to skip ahead, the answer is yes, you can do it too, because the framework is open source. So I won't harp on this. This is the food pyramid of testing that you've seen like 4 or 6 times by now. And end-to-end tests, of course, is the meat and sweets area that you should use sparingly. And unit tests are the bread and the veggies and stuff. So I won't harp on this because I'll sound like the FDA, but our framework is focused on the end-to-end test part. And there is a good reason for that. Unit tests are very important. You have to have a lot of them. They're your primary testing type. But especially for mobile devices, end-to-end testing is very important because, like I mentioned, mobile devices interact very much with things around them and the environment. They might want to send data to other devices, peer-to-peer. They might want to discover what's around them. They want to discover a Bluetooth beacon or another device. They might want to talk to a device in the Internet of Things. They might want to talk to a light bulb or a fridge or a VR handset or a watch. You might need to care about what your network is. It might be cellular. It might be Wi-Fi. It might be a low-quality signal. It might be 2G. And your app might behave differently in those conditions. It might behave differently under bright lights or under low battery conditions or on a low-spec device versus a high-spec device. And depending on the performance of your network. And of course, you also probably interact with some sort of cloud backend service. You receive data from it, you send data to it. So you can't test a mobile app in isolation just by itself and have a good picture of how this app will work for users. But the thing is that that's what we do, right? So most frameworks that exist for mobile testing are very much single device based. You create an instrumentation or a JUnit of some kind, sometimes not even a mobile JUnit. You use a roboelectric, which is fantastic for testing single units and is very important for making sure that your algorithms work and for mocking your dependencies and things like that. But ultimately, it doesn't answer the question of does the whole app work. And even if you don't use roboelectric, you can create a JUnit that runs on device or using Espresso or UI Automator or something like that and run your test. But you're restricted to just the device that you're on. And we've seen presentations about labs that allocate you a single device and your entire environment is restricted to that device. So using multiple devices is step number 1 for end-to-end tests for mobile devices. Other issues are you need to trigger complex actions on multiple devices. You might want it to start connecting or sending a message or connect to Bluetooth or switch the orientation or start scanning or something like that. You might want to trigger your own SDK or make a call in software that you wrote, like arbitrarily complex things that nobody can prepare for you. If you have multiple devices, you need to synchronize them. So you have one device that sends a message to another device. You wait for it to be received, or place a call, decline the call, make sure a voice message appears, for example. You might need to drive a wide range of equipment in your tests, so you need to somehow handle the drivers for that, the way to synchronize with that, how to talk to the hardware, making sure it's hooked up to the device, making sure it's allocated together with the device, making sure that if you have an attenuator here and a phone here, you don't think those are somehow related in any way. You have to group the devices together. And of course, you need to communicate with cloud services, like I mentioned. And when you're done, you need to collect the debugging artifacts and logs from all of those different places to get a consistent picture of what your test actually looks like. So we've tried very hard to address some or all of these issues. And to do that, we've created a framework that we call Mobley. It's open source, and you can use it too. And to tell you more details about that, I present you Ong Lee.
Thanks, Alex. Oh, it's weird to hear yourself. Hey, I'm Ong. I work on Android OS. As Lex laid out, we have a mountain of problems that we need to address. So we created this framework, and we chose Python because it's very descriptive, and most of our developers probably don't want to think about all the crazy language stuff. When you write tests, you just want it to work. You would prefer to write in English, but unfortunately we couldn't do it today. So our test logic runs on the host machine. Because when you're coordinating multiple devices and many different types of complex interactions, it's much easier for a human to read a piece of code, say, oh, this is what this code do, as opposed to separating 10,000 different places. It also makes the debugging much easier since you have a single point of logic. And then we bundle it with some essential libraries that you can use right off the shelf. Obviously, being out of Android, we do Android device very well, as we'll demonstrate later. We also have some RF components like attenuator and monsoon. We'll open this code up in phases. And we also make it very flexible and pluggable. As you've seen on this conference, there are everybody has their own build system and workflow in their company, and you probably don't want to throw away everything you have just to use one thing. So very much like the Open HFC guys this morning, our stuff is also a library that you can easily integrate with your workflow. And it's open source. So we've been actually running this inside the company for a year now, and there are about a dozen different products that runs on this platform, and we think it's mature enough that we want to share it with you guys now. So this is the basic architecture. As you said, we don't deal with test allocation, device provisioning. This stuff, we leave it to your existing system, or as you know, like TradeFed, these established systems. Then we focus on the part that exposes these devices to you in your test script. So Mobley runs on the computer, and it just basically it's very similar to the Python PyUnit format with a few caveats, because we found out that unit test frameworks don't necessarily satisfy the system testing requirement. For example, you probably want some device recovery logic to be executed if something goes crazy wrong in your test. So we build those callbacks into the system. And also probably simple assertion may not be sufficient for device testing, in that you probably want to attach extra information in what went wrong, the device stats, or some numbers in your assertion while you leave the test. So we've built that too. And as Alex mentioned, so in our concept, our tests don't operate on a single device or a single entity. We operate on a collection of them, and the collection can be composed of really anything. It doesn't have to be just like consumer electronic devices. It can be some equipment in very close to hardware domain, or it can be some software service that's in the opposite direction. So we codify this concept called testbed in our framework. The testbed is just the unit of things you operate on in your integration test. As you can see, it could obviously has mobile devices. It could have 1, 2, 3 multiple Android phones. Then it could have RF components, attenuators, or call boxes, and simulate the entire telephone network. Or it could talk to cloud services like App Engine, or your own backend that your app uses. Or we'll even have teams testing like network switch backend using this framework inside the company. And then we'll just go through, I really like Adele. We'll just go through a simple test just to show you what it looks like. So before that, we need a config file. The config file just describes what the testbed is composed of. It can be, here we're just having, this is just a syntactic sugar to pick up all the Android devices. then this is the code. It looks very much like a PyUnit test. And you set it up, and in the setup process, you are declaring your hardware dependency, so the test can, if you don't have this device, we will fail, we won't execute. Then you basically here we're declaring we need an Android device here, and we call it .dot. Then we make a toast on it. And when you execute it, it will execute exactly like a Python unit test with a config file. So there are some other cute features we added in, like, most of the device tests will require tons of parameters, and you can pass it in easily. Or we have a more sophisticated way to declare Android device dependencies. Let's say you have a test, then certain Android device play certain roles in this test, and you want the signal somehow correlate that information to the test without hard coding the serial numbers. So that's the design there, and you can attach other values like phone number. You may think, why do I need to attach phone number since Android should have that API? Well, it turns out it doesn't work very well, that API. So we have this because we have had so much time to run internally, we added these cute features like, I just want to log something related to this device. We have this special logger inside the Android device object that you don't have to always log your serial numbers. So as I promised you, we're from Android. We do Android very well. So in Android, there are many ways to control an Android device. It's not just, so obviously you have the ADB, that's the basic. Then you have the UI Automator. We're using the UI Automator open source project here. Then you get into, like, most people kind of stop here. But it's certainly not enough for Google to be able to test our platform. So we added all these other ways to test to do deep dive into the system. And all this control comes in the single object. So that object has flexibility to accommodate this, and without your test having to look like 4 different handles to the same device, then you have 2 devices, just goes crazy. So Alex will talk more about the Java control here.
Sure, thank you. So as Ang mentioned, the point of having devices in your test is to control them. There's lots of ways we can control. I'm going to do a deep dive on them. But just in general, I want to say that different multi-device frameworks have different approaches to controlling devices. So last year in 2015, we had a very interesting talk by Uber about how they did their multi-device control. And just today, we also had a very interesting talk about, actually it might have been yesterday, Intel's approach. And both of those approaches were decentralized. So the main logic was on the device, and you would use sort of a signal and slot system or a locking system to block and then wait for something else to happen. And our framework actually takes the opposite approach. It's centralized, and your test logic is on the Python side. And we feel it's a lot easier to manage the dispatch and return and synchronization of multiple devices and the debugging because all of your code and logic is centralized. But it makes it a little harder to dispatch particular logic. So the first step to dispatching logic is Android API calls. There's a rich Android API. It's in Java. It runs on the device. You might have multiple devices in your test. How do you trigger actions? So there's an open source project called SL4A, which stands for Scripting Layer for Android, which basically exposes the Android API as facades. It has essentially an RPC calls, and we have integration with that. So we just call an RPC on the SL4A side. It's an app that you install on your phone. So Make Toast in this particular example is an RPC that's defined by SL4A. You call it, and internally it'll implement the call using the Android API and return back. And we have created a special extended version of SL4A, which is also open source. It's available in this link, which you can find on the GTAC website after this is over. And it will essentially expose also the system and hidden and private APIs. If you want to do system testing or Bluetooth or Wi-Fi or airplane mode, all that stuff, it'll allow you to call those methods. But this is just the Android API, which is not sufficient because chances are you're not developing Android and you have your own app and your own SDK that you care about. And also because SL4A requires system privilege, which could require installing an AOSP build of Android, it gets kind of hairy. So to do that, we have custom snippets, which are custom, basically just like SL4A callbacks, but you write your own code and you expose that to the RPC server. So from the Python side, you can invoke your own Java code at any time. And now you can use it for your own SDK calls, like JUnits, you can use it for Espresso, whatever else you want to run on the device. This is a very simple example of the Java that you might write. In this situation, I just wrote a Java function that appends a prefix to an input integer. Of course, in reality, this would be much more complicated. It might be an SDK call or something. And I extend the interface snippet, which is very bare. It just basically has the shutdown method in it. And I tag my method as @rpc, which is what allows the system to find it. And then in your manifest, you just declare the particular classes that happen to have snippets in them. And then you build it into an APK, and you added our library to it, which we will very soon expose on Maven Central. This won't work yet, but it's under the last stages of review. And just by including this jar into your APK, into your Android tests APK, you will get all the functionality that RPC server required to make these calls work. So when you build the APK and install it on the device, that is the APK with the RPC server. On the Python side, you just call load snippets, which will go and start up that app with that package name, connect to it, and then automatically find all the methods in it that are tagged with @rpc. And then in your Python code, you just call get foo, and there is your answer. Foo2 was what your Java logic was. And you can use this like for Espresso, for example, in this situation. You can use it to drive your app. You can use it for arbitrarily complex things. But there's more in the world than Android devices, so you might want to hook it up with your own toys, with your own hardware, and Ong will tell you how to do that.
Thanks, Alex. All right, now you can wake up the people who don't work on Android. So as Alex mentioned, you probably want to have your own robot, your telepresence magical machine to test to involve in your test. So like this morning, you saw the approach of the pluggables in the other frameworks. So we kind of thought of the same thing. We want to make it very easy for you to migrate your code over. Likely, you probably have something already working. So we intentionally did not choose the inheritance way because I know programmers really don't want to change their code, and especially the basic inheritance, and it's kind of hard to do in Python. So we have this very loose interface in the Python module. You just tell us how to create your object, how to release it, and how to get information from it. So for example, let's say we have something like a car. Then you just, same as Android device, you declare the dependency on its registration. Then you can move on to do actions on it. And I know it's not much, but like for various devices, you probably have various levels of controls or protocols. For example, some goes through PySerial, some goes through the USB protocol. So the pre-bundled libraries kind of provide examples on how you can interface different kind of devices. Or the design pattern there is there for you to kind of take a look and see what you can take away from that. And with that all said, we have a video to show this in action. So I just explain it because the video doesn't have any narration. So you'll see three devices. You'll see two phones and one wearable. And one of the phones will make a voice command, and the wearable will take the voice command and interact with the other phone. So
make a phone call, Daddy.
Oh, the audio's not working. So this is a phone that's called Daddy, and the watch calls Daddy. And you can see now it's placing the call, and the other phone gets a call and just hangs up. I don't want to talk to him. Yeah. Go back to the slides. Right, so this is actually written by some just random team inside the company. We've never talked to them, just read our docs and wrote it, and they demoed it to us. We were kind of, oh, wow. So this just shows you how easy it is to use it. And this whole test is probably less than 50 lines, and including the assertions and stuff. So, and coming soon, now you can wake up the non-Android people. We are working on iOS very hard, but yeah, it all depends on what Apple lets us to do. So then we're bringing async events into Snippets because most actions on Android are callback based. So it might be useful someday. You might want to have some async logic. And we also want to provide a single set of libraries for you to interact with Android because not everybody wants to write that 20-line function to connect to Wi-Fi. And it's kind of sad that it takes 20 lines to connect to Wi-Fi in Android too. And that's it, thank you. And we have some sources. Our repo just went online like 2 weeks ago. So we'll keep pushing documents and codes through, but it's just the logistics from pushing code from internal to external. Yeah.
Mobley is already up. The snippet lib will be up in the next few days, going through the final stages of review.
Excellent. Okay, Alex and Ang. Just a note, after this talk, we're heading into a break, so if anybody needs to get started on a break, that's what will be coming up. But we'll go through some questions until then. First of all, how does this compare to everything else we've seen at this conference?
Right. I suspected that was going to come up. We didn't actually know each other until we met here. So I actually talked to them. They're very focused on the hardware teams that actually have to deal with manufacturing and stuff. We are more focused on the device side and like apps, libraries, these more higher level stuff. And we have that's kind of the focus. And our approach is slightly different. For example, the class inheritance. And also, we don't ask you to declare your hardware dependency for every single test case, which is kind of the case in HTF. Just these small things. We do look forward to collaborate, since probably not everybody have to write the same library twice in their slightly different formats. Yeah.
So there's kind of two pieces. There's the test runner that actually kicks off the test, collects results, and things like that. And then there's the set of devices and APIs that it ships with. So there's actually, it seems like there's a lot of overlap between OpenHTF, the runner, the kicker off, and the Mobley runner, which would be collaborating with them quite closely. But in terms of the bundled library, it seems like they're more focused on hardware devices, like Ang mentioned, whereas we're focused a lot on Android and APIs and software and being applicable to app developers, not hardware developers. But we'll be talking to them.
Very good. Always good to talk it out. If there's any questions in the room, go ahead. You can raise your hand as well. I think we covered that. Can we use the real devices and emulators, simulators, both with it?
Yes, because we don't really make assumptions. So our controller for Android device really just takes an ADB connection. And if you have an ADB tunnel into your simulator, that's fine. And we're also working with some other team to cook up something really cool. But I can't really say that. Yeah. But real device and simulators, a mix is fine. Yeah.
Yes. What's the biggest challenge in taking this from internal to open source?
Internally, there are a lot of magical tools in Google that we don't have to write. And yeah, but open source, then we can't. We're still just figuring this out. Yeah.
There's a big set of utilities that we have internally that are pretty closely tied with other utilities that we have in particular teams that are working on them, that are changing them all the time. So the process of trying to abstract that into a public, stable, useful, consistent set of utils for the open source release is something that's still ongoing for sure.
Yes, it is very hard to do. I know that. What about the test result? Do you have any dashboard available?
So the framework is designed to integrate with a test runner, so that's why it doesn't handle things like device allocation, shipping files around, and sending results back. The results go firstly into the summary JSON file that is part of your log directory for machine parsing, and secondly, the test case itself is executable, and the exit code of that execution is non-zero if the test failed, just like PyUnit would be. So we're hopeful that wherever you can sort of plug in PyUnit or a generic command that runs a test, you should be able to plug this in. We're definitely working on better integration with test runners, which will provide dashboards and results and execution and things like that. It's a little hard to focus on it because we have tools internally that we're all already using that are excellent, but that we can't release. But we're going to try and make something in the future.
Okay, I think we'll do one more before the break. Is the configuration or implementation easy as compared to another open source tool?
What's another
Or did you make your configuration so difficult that
Personally, I can say it's pretty easy because I'm a very lazy person. I really don't want to have to go write 3 different files in different formats before I can run a test. That was just too difficult for me. So we just have this one config. It just really describes what the testbed has and how to find it, like say a unique serial number to your device or a network address. So that's really all we want. You can go as crazy as you would like in the config, since it's just a JSON. We do have teams that do that, where the configs are just they would encode the entire encryption key in basic C4 string and tons of them. So yeah, but for me personally, I prefer to stay on the easy side.
The config, you can attach your own parameters to the devices. You can create your own devices and their own config keys, and you can have params at the top level that just get passed directly into your test case. So it is very configurable. And the basic config, as you saw, is very simple, and it can get arbitrarily complex. So it's quite configurable.
Ah, great. Well, yes, that brings up a good point. When choosing a testing tool, make sure the developer was very lazy beforehand, and that's a good signal that'll be easy to use.
Until you need bug fixes.
One thing at a time. All right, another hand for Alex and Hank.